All right, here they come. Good morning, guys.
Good morning.
All right, I think, Christian, you have my favorite background I've seen so far. That's obviously a digital background, right?
Yes.
Yeah, I dig it, man.
Thank you.
Just thought I'd let you know there. All right. Well, it's good to see everybody here. You're going to need graph paper and your TI-84 and Desmos today as we get started here. So get your get your notebook out, meaning your graph paper notebook or whatever you have. We're going to be out of student workbook today and getting you guys ready for section 9. So call it prep for 2.9 log review. Section 9 is a challenging one in some respects because the mathematics are a little bit more involved. They take logarithms to solve the word problems or the financial problems that we have in section 9. So today is all about getting you guys ready with the mathematics involved with section 9 there. So you're going to need quite a bit of graph paper here. So get out a notebook or whatever you have. You're going to need your TI-84, and if you don't have the TI-84, you're going to need your Desmos. So like I said up here, when I have Desmos up here, just type in desmos.com and hello. Type in desmos.com/scientific as you see up on my screen, and you'll have this calculator here, either one. So either use Desmos or TI-84. I'm going to show how to use both. I like Desmos in a lot of respects because it looks identical to what we have, exactly on your paper here. So Desmos is kind of cool to use. I'll be using that a lot today. We'll be using the chat a lot for working together here as usual. And I will also be calling upon you guys to speak up in class and share what you guys are coming up with here. Everything that we do is going to be scanned and submitted at the end of class. So keep that in mind, as I stated right here on my notes on my screen. And we're going to have a little mini quiz at the end based upon what we cover. So no. It's on the review that I'm going to go over here, Jacqueline. So everything that we cover here. So I'm just going to do a log review because it's probably been a long time since you guys dealt with logarithms since Algebra 2, if that's where you guys came from last year. Or yeah, I never test on future stuff. All right. I'm a fair guy. I wouldn't do that to you. I just want you guys to be, working with me, paying attention, to make sure that you're working with me, especially if you don't have your videos on. You're going to have to submit your work with the quiz after we are done, before 2:30. So just keep in mind, just work with me here. The goal today is to get you guys prepared for section 9 because it's a lot different, and the mathematics, like I said, are a little bit more involved. So today's is preparation day. All right, so we're taking the day off of the student workbook here and just working. I laughed because I was reading your comment there, Jacqueline. Taking the day off just to get you guys prepared. Oh my gosh, Maddie, I actually see you today. Nice. All right. It's good to see you guys. That's one of the big things I miss. Oh my God, there's Jay Ron too. Look at that. Here we go. I miss seeing you guys. I miss hearing your voices. I miss all those things that we take for granted on a regular basis, if we were in school. So when you guys speak up, and you guys actually turn your videos on and you actually speak to me, it is nice. I tell you, I really enjoy it. All right, so we're going to try to do a lot more of that. I see Kylie now, very good, and Craig's coming in. And I see Getsy, very good, Matthew, Adiana, awesome. All right, so thanks for you guys turning your videos on. We're going to be using Desmos quite a bit, so open up a tab. Even if you have a TI-84, I want you to use it because Desmos, I'm talking about the scientific version right here. So you got to go desmos.com/scientific. Look up in my address bar up at the very top. Desmos.com/scientific. Okay, it's free and it can do everything that you're going to need to do. All right, so title your notes. appropriately here and get ready to rock here, and then we will get started. We almost have a full class now, so the timing is pretty. You guys are getting better, okay? The 28 people that are with me right now, pretty good on time. Very good. All right, type in ready to rock here in the address bar when you're ready to go here. Let's get started. We have a big review today to get you guys ready for section 9, which is obviously next week, not this week. Okay, I'm taking a day off to just do a full log review because it's not easy stuff, and I want to make sure that you guys are good. Okay. All right. A lot of you guys are ready, and a few of you guys are even ready to rock, like Kyle there. Very good. Okay, like I said, title it, okay, right up here at the very top. This is a prep for the next section here. And it's going to take a good hour to hour and a half, I predict, because you'll see I have to go through a variety of problems here because there's a lot of different cases involved dealing with logarithms, and I want to take you through it here. So here we go. Time to rock and roll here. Okay, so the first thing we're going to do is we're going to start with powers of 2, 3, 4, and 5 because logarithms are exponentials. And if you don't know your exponentials, like powers of 2, 3, 4, and 5, it could be difficult for you. It could be rough. So we're going to go back to basics here in the beginning, and I'll take you through the review. So here we go. Let's call the first one powers of 2. If you don't know what I'm talking about, I'll lead the first one, and then we're going to go through powers of 2, 3, 4, and 5, all the way up to base 5. And then I'm going to get you guys involved. So get ready to turn your mics on and orally participate with me. And all I ask is you to try your best, do your best. And obviously, if you get stuck on something, that's my job. I'll help you out, I promise. Okay? So here we go. We're going to start off with 2 to the negative 2 power. 2, and this is no calculator here. No, don't use a calculator. You should use the one between your ears. Only use the calculator when I do. If I need one, it probably means you need one. Okay, now when you have 2 to the negative 2 power, that reciprocates it, and you get 1 divided by 2 squared, which is 1/4. So when you have negative exponents, you get fractions because it reciprocates the base. You can even test that out on the calculator if you like. Everything I say can be justified with the TI-84 or Desmos, one of the two. Okay, so 2 to negative 1, that's 1 over 2 to the first, which is obviously 1/2. Like I said, I'm going to do powers of 2 to kind of refresh your memory here, get you going, and then I'm going to ask you guys to help me out on the other ones. Okay, 2 to the 0 power. What do you guys remember about that one here? What's any number to the 0 power?
1.
There we go. All right. So it's equal to 1. The only exception to that rule is 0. 0 to the 0 power is not 1. Okay, it's indeterminate. You can check that on the calculator if you want. Okay, and so 2 to the first is obviously 2. 2 squared is 4. These are obvious, hopefully. 2 to the third is 2 times 2 times 2, which is 8. Okay, and then 2 to the fourth, that's high as we need to go, is 16. And you'll notice here, when I say powers of 2, you obviously multiply by 2. So this is doubling. Each time it gets twice as big, and that's why they call them powers of 2. Or if you go in the other direction, if you go up instead of down, you divide by 2 instead of multiply by 2. Okay, let's talk about powers of 3. We're going to do powers of 2, 3, 4, and 5, and then I'm going to go to logs, okay, because they're related, believe it or not. Okay, so let's start off with 3 to the negative 2, 3 to the negative 1. Go ahead and work on your own pace. I'm going to ask one of you guys to help me out with this here in a minute. I'll give you about 60 seconds. Let's do a few. We don't have to go crazy. I just need to know or make sure that you know how to develop powers of 2, 3, 4, and 5. Okay, so work on that. And everybody with the videos off, just keep in mind, I'm probably going to be picking you guys first to participate today for the most part, because I want to make sure that you guys are really working with me here and participating. If your video is off, you better be in the chat participating, just to make sure that you guys are doing the responsible thing behind your computer screen. Okay. So let's, like I said, we're just going to go randomly around the room. When I ask you to turn your mic on and participate here, just give me your best. And like I said, if you need help with anything, I'm here for you. That's my job. Okay. Melina, we're going to start off with you. Will you turn on your mic and just help me out with the powers of 3, please?
The power, okay, 3 to the negative 2 is 1/9.
Keep going. I'll just write as you speak.
3 to the negative 1 is 1/3. 3 to the 0 power is 1. 3 to the first power is 3. 3 to the second power is 9. And 3 to the third power is 27.
You're awesome. Thank you. All right. Let's keep it going here. We're going to talk about powers of 4 and 5 as well, just to make sure that you guys are familiar with these things here. So let's take 4 to the negative 2 power first. Work on your own pace right here, and I'll call upon somebody in a minute. And if you have questions on anything, speak up as we go. Don't wait till the end of the lesson, to ask me questions. We ask as we go. All right. That's the way we do it in here. All right. Take a moment and work on your powers of 4. All right. Craig, can you help me out on this one, please?
You say me? Me, Mr. Ainsworth?
Yeah, a little bit. Just go ahead and speak up really loudly on your end. I'm going to turn up my volume here. Go ahead.
Like for you just want me to go like in order down?
Yep. Start at the top before the negative 2 power.
4 to the negative 2, would that be like 1/12?
Well,
Or
not
no?
12, because these become fractions. So you want to reciprocate the 4, and you want to take it 1/4 squared. You got to be thinking 1/4 squared. The negative exponent shifts it to the denominator. You get 1/4 squared, which if you simplify it, what would you get, Craig?
1/16.
There you go. So 1/16. See, anytime you have a negative exponent, you're going to get these fractions. How about the next one? What do you get on 4 to the negative 1?
It'd be 1/4 to the first power, which should be 1/8.
No, be careful. It's 4 to the first power.
Or 4 to the first. Let's
So
just see. We'll just do 1/4.
just 1/4, because 4 to the first power is just 4. Okay.
Yep.
Raising, something to the first power doesn't change it. How about 4 to the 0 power?
Just 1.
Okay. Keep going.
Then 4.
Good.
Then 16. Then
Go ahead and do it on your paper if you need to. Go 4 times 4 times 4.
yeah.
Okay.
Uh, 64.
Yeah, there you go. Okay, good job. Thank you. All right, let's switch to powers of 5 now. Okay, here we go. Let's look at 5 to the negative 2 power, 5 to the negative 1 power, 5 to the 0 power, and so on. Let's go all the way up to 5 cubed. All right, take a moment and work on those, guys. All right, let's, Hannah, can you help me out with this, please?
Yeah. So for 5 to the negative 2 power, I got 1 over 25. And 5 to the negative 1 power is 1 over 5. And then 5 to the 0 power is 1. 5 to the first power is 5. 5 squared is 25. And 5 cubed is 125.
Awesome. Thank you. All right, now let's take these and let's use them. Okay, so I want to talk about how to evaluate a log. We'll do some basic log work first here. So this is number 1, write down evaluate each log. Let's put that in red too. Evaluate each logarithm. Okay, and these first examples, we're not going to use a calc, so without a calculator. So no Desmos, no TI-84, no scientific calculator, okay? The only thing you need to do, or use actually, is what you saw above right there. The only thing you need to know to evaluate each of these logs that we're going to talk about are the powers of 2, 3, 4, and 5. And you have to know how to switch from log form to exponential form. So this is the reason why I'm doing this today, is because it's probably been a while. I mean, I don't know, at least 6 months for you guys, because this is usually an Algebra 2 topic in first semester. So it's probably been like 9 months since you've seen logs, if your last course was Algebra 2. And if it wasn't, if it was pre-calc, you saw them in first semester as well. Okay, so here we go. So I'll leave the first one here just to get you guys thinking, right? And then when I say lead, I'm going to model something. So I'll show you what I'm thinking. And then afterwards, I'll give you a few more, and we'll go around the classroom here and just kind of play around with the idea. Now we want to figure out without a calculator what the log base 2 of 8 is. So first of all, you have to understand that 2 is the base. Okay, so let's talk terminology here a little bit. 2 is called a base. So the way you say this out loud verbally, like I am doing, you say log base 2 of 8. That's how you say it. Log base 2 of 8. And the 8 is called the argument. So go ahead and just put the names down so that you understand which is which. One of the misconceptions about logs is that kids just don't know what the 2 and 8 represent. And if you don't know what they represent, it's kind of hard to work with them. And logs are probably one of the most abstract Algebra 2 and pre-calc topics there are. That's why I'm doing a little review before we go right into the financial problems in your workbook. That'd probably be a bad move on my part just to assume that you remember every single thing about logs. So today is all about reviewing, okay? So here we go. I'm going to transform this to exponential form. So let's write that off to the right. Exponential form. So when you look at a log, you got to train your mind how to think about it. So when I look at log base 2 of 8, I'm thinking this in my mind. I'm thinking 2 to what power gives me 8? This is what I'm thinking in my mind. I look at the base, which is base 2. Notice the same base right here. This is the base. I say it in my mind, or I think in my mind, 2 to what power gives you 8? And you guys know what that number is. The people with the videos on, show me on your fingers, and everybody else put in the chat. Well, 2 to what power gives you 8? I see a lot of you guys. You're saying, yes, it's 3. Look right up here at the very top, okay? We did the exponentials already. It's a power of 2. 2 to the third power is equal to 8, okay? So x has to be 3. So this tells me x is 3. It also tells me that the log of base 2 of 8 is 3. You don't need a calculator for that. Not on this one, that is. There are a lot of cases where you need a calculator. We'll get to that in a little bit. Right now, we just want to play with logs, get it familiar again in your mind because it's been a long time, probably 6 to 9 months at least, first semester last year. Okay, so let's try something else. Let me get someone else involved now. Get you guys involved, that is. Log base 4 of 16. Okay, so start with the base. Now this is base 4. Write it off to the side. Write exponential form down like I did on the previous one. And then think about what this log should be equal to. Emily, can you share your thinking on this one? Gonna speak up a little bit louder, please, so I can hear you better.
2,
Okay, so why is it 2?
because 4 to the second power is 16.
There you go. All right, very good. So 4 to what power gives you 16? And she said 2. So this log is simply 2. There you go. It's that simple if you know your exponential. So let's try a few more just to get it down here. Log base 5 of 125. Log base 5. Now we're base 5. Log base 5 of 125. What should that be equal to? David, can you help me out with this one?
It would be 3.
Okay, can you explain why?
Because 5 to the third power would end up equaling 125.
Very good, very good. So 5 to what power is 125? He said 3. All right, 5 cubed is 125. You can look above. We did that. So this log base 5 of 25, 125 that is equal to 3. All right, now let's make sure that you guys know something about the natural log. So let's talk about this natural log. Does anybody recall the base for the natural log? You guys, can you either say it or put it in the chat? You guys know what the base of a natural log is?
Is it 10?
That's the common log. We'll get to that in a minute. Okay, everybody read the chat. It's base E. Okay, it's the famous Euler's constant, 2.718. Okay, so and the natural log abbreviation is ln. So here we go. Let's try one. So natural log of E. What would that be equal to? Again, these are not calculator questions here. I'm not asking you to use Desmos or the TI-84. What do you guys think? Give me your guess in the chat on this one. Don't be afraid to try and not be correct. You know, I don't expect perfection in the practice session. I never expect perfection. Don't worry about that. Just try. What do you guys think this is? Use the same skills as the previous ones. Okay. Let me give you a little hint. Look at the screen here, guys. Natural log of E is the same as this one. Log base E of E. The natural log is base E. That's just another way to write it. Now what is it? You should be able to see it now. Transform to exponential form. So Matthew, talk to me here. How do you know that?
I know that because they're both E, and like it'd be the same thing as using like one and then like one on the bottom and one on the top, which is like still 1. So it would just be the exact same thing. So you just put 1.
Can you transform it to exponential form for me like we did the previous one?
Oh yeah, because it goes into that that many times. So it'd be 1. So
okay, so exponential.
Yeah, because that's why it's because. Wait, hold up. I think
it's okay. So that's okay. You start off with the base. It's base E, and you always ask yourself the base, which is E, to what power x? You know, x is some power gives you E. And you guys, what's the exponent on any number when you don't see an exponent? What's that exponent? On any number, any variable, what's the exponent if you don't see one? Yeah, it's 1. So if I put a 1 there, look at this. X has to be 1 here, guys. And if x is 1, e to the first power is e, all right? This has to be equal to 1. So remember this. This is one of these key things that's going to come up later on, so you better highlight that one. Natural log of e is 1.
I found out a way how to do it. Okay, so what I did was I took I took the log on the bottom, and then I divided it by the log on the top.
You gotta be careful of that. That's I know e divided by e gives you 1, but that's not how you think
Oh no,
about it.
I'm sorry, I meant the right one. I divide the right one, the big one, into like the small one. So, yeah, I'll just show you like an example on this. Like, I don't know if you guys can see, but like on like I would divide, I'd put like the log of this number, like 25, divided by the log of this number 5, and then I would get like, then I would get the log of it.
I'm not sure, Matthew.
Let me do it. Let me see if it's right. I don't know, because that's how I got it. I'm just really
Okay.
bad at explaining it.
It's okay. It's okay. That's my job anyways, but you're doing all right.
Yeah,
Just keep
this
thinking.
like this. Look, see, you get the get what it's equal to, or you get what how many times it goes in. That's what I meant. Sorry, you get how many you get like what the exponent is if you do
Okay.
this. So, yeah.
If that works every single time, Matthew, go for it. I think about it as just take the base, the base to what power gives you that number. In this case, it's got to be 1. E to the first power is e. All right, fair enough. How about this one here? Last one, and then we're going to go to an actual, the main property that we need here today. So here we go. How about natural log of e to the 5th? What would that be? Think simple. If it helps you to think about it and rewrite it like this, you can do that. These are the same things. The natural log is log base e. Mondo thinks it's 5. What do you guys think? Talk to me, guys. I have 31 bright students with me here. Okay, so when you take the base right here, you always start off with the base in your mind. And you say e to what power gives you e to the 5th. And because the bases are the same, the exponents must be the same. So in this case, it has to be 5. Let's see if you guys are really understanding me here. What's the natural log of e to the 10th? There's an obvious pattern going on here. Okay, it's starting to click for some of you guys now. So this is nothing more than log base e of e to the 10th. So when you start off with the base and you ask yourself, e to what power? E to what power gives you e to the 10th? If the bases are the same, then the exponents must be the same. So this log better be equal to 10. Okay. All right. Now let's get into the main properties of logs that we need for today's lesson and also next week in section 9. This is called the exponent property of logs. At least that's what I call it because it deals with the exponent. Okay, so I just refer to it as the exponent property of logs. Okay, it really doesn't have a name, but it deals with the exponent, so I just gave it a name. And it goes like this. So let me state it as you would see it in, let's say, a math textbook, and we're going to apply it because this is the main thing that we need today to solve all your financial problems that we're going to see in section 9. Okay, so it states this. It states that if you have any log base b, so notice I put a b there just in general because this works for any base. So if you have log base b of, let's say, x to the y power, make sure you write it correctly right there, guys. Notice that it's x to the y power. So again, this is the base. B is called the base. And notice our argument is x to the y power. And notice that this y here, right here, that's the exponent of the argument. That's why I'm referring to this as the exponent property, because what we're going to do And what we need to do when we solve these financial problems in section 9 is we need to apply the exponent property of logs, which deals with this. It says, hey, take that exponent. Look at me first, guys. Look at the screen. It says, you could take this exponent here and shift it in front of the log as the coefficient. So I can rewrite it as y times the log base b of x. So let me just write it down what I did in simple words so you guys can think about it correctly. This property here just shifts the log, okay? It shifts the exponent, all right, to the front of the log. That is the easiest way I can explain it. And here in a minute, after I illustrate this, you'll see where it comes out, because in all the financial problems that we're going to be solving in section 9, we're going to use this property every single time. You're going to see that here in a minute. So let's kind of, before we get to the financial problem though, let me illustrate how it's done, and then you guys can play with it too a little bit here. So let me give you an expression here. So let's take log, let's say base 10, which is your common log, 3 squared. Okay, so notice that we're base 10, we're taking log base 10 of 3 squared. Now I see that we have an exponent of 2. So I know by looking at that property that I can take that 2 and shift it in front of the log, and I can rewrite it as 2 times, all right, log base 10 of 3. Now, logs are really abstract. That's why a lot of students, when they go through Algebra 2 and pre-calc, when you deal with logs, they go, what the hell are we doing? You know, what is all this stuff about? So what I want to do right now is just show you that they actually are the same. So everybody get your TID4, or you can use Desmos, either one. I'll do it both ways, because you guys are going to have to use Desmos as well, because I know that not everybody has this TID4 handy. So I'll do it both, because I need to make sure everybody's good here. So the common log, which is base 10, this is called the common log base 10. It's the one you see on your TID4, the button that says LOG, that's base 10. That's your common log, base 10. It's on the TID4. So I'm going to illustrate on the TID4 first. So everybody hit the log button, work with me if you have the TID4, and then I'll switch to Desmos in a minute. Okay, we're going to take log, and you notice that the base is not there. When you don't see a base on the calculator, it's base 10. Okay, if you didn't know that, then you just learned something. All right, and then enter in 3 squared, and then hit the enter button, and you notice it says it's 0.954. This decimal never ends, it never terminates, and there's no pattern. It's one of those irrational numbers. So let's just take the 3 digits of it. Okay, so 0.954 approximately. Now, if this property is actually correct and valid, which it is, then the right-hand side, 2 times the log base 10 of 3, that better be the same decimal. So let's try it again. So let's 2 times, let's try it. 2 times the log, and then just type in 3, not 3 squared. And then hit the enter button, and you'll notice it says 0.954. So the exponent property of logs is actually valid. It actually is just another way to write the expression in log form. And in a minute, you'll see why I'm going over this. It'll become clear. I just have to go step by step. If you're using the Desmos, then you watch closely here. You got to use your function button. So hit function, and then you'll see the log button. LOG is the common log base 10. And we're going to enter in 3 squared. So you got to go back to the main, type in 3, and then square it. And you'll notice it has the same value, 0.954. Now let's evaluate the right-hand side, 2 times the log. So enter in 2, and then hit the function button, type in log, and then just enter in 3. To do that, you got to go back to the main screen and hit 3, and you'll notice that it has the same value. So it doesn't matter whether you use Desmos or TID4, you just got to be good at one or the other one. Okay. Jack, are we all good? Okay. Which one are you using, the Desmos or the TID4? Oh, so Jack, no, okay, Jacqueline, I was talking to Jack too, though. Jack, what are you using, the Desmos or the TI-84? Okay, either, so both Desmos. Okay, that's fine. Okay, so this is valid. So let's try, let me have you guys try it. So if I give you this expression here, log of, let's say 4 cubes. Okay, let's just play around with it a little bit here. Charlize, let me work with you on this one. How can we use the exponent property on this one and rewrite it? Charlize, are you there? Tiger, come on. Okay, can you just turn your mic on and help me out here? Just try to apply the exponent property here. Give it a shot.
So you would have you would take the 3 and like make it multiply times log.
So go ahead and say the whole thing. So 3 times the log of what?
Times the log of base 4.
Oh, base 10 of 4. So when I don't show the base is right here, 10. If I don't show the base, it's assumed to be base 10 of the common log. Yeah,
Oh.
but you put the exponent in front, so that was good. All right, good job. All right, let's just play around with that just one more time. Sometimes we deal with the natural log, so sometimes you end up with something like this right here. So the way you say this is the natural log of 5 to the 6th. The natural log of 5 to the 6th power. Elijah, can you take this one here? Not asking any calculator work here or anything. Just rewrite it. Using the exponent property. Elijah, come on. Okay, so this is why I said, having the videos off is not good. Are you there, buddy? Come on.
Can you hear me? Hello.
I can hear you now. Go ahead.
What's up?
I already asked you the question. Where you need to be
I was
here.
talking to my brother for a split second and out the way. You want me to make that into exponential? What you're asking?
No, just apply the exponent property. I'll come back to you. To stay with me here. All right. Try to stay with me and be involved.
So far, but yeah, I got it.
Okay. Nathan, take over.
6 times the natural log of 5.
There you go. And that's it. That's all there is to it. That's all we have to do to apply the exponent property. Now, let's get into a financial problem. Here we go. So this is number 3. This is what you guys are going to need to be able to do in section 9. So let me pose the problem. Okay, so here we go. So let's write this together. So how many years? Okay, how many years will it take? All right, to let me see, how many years will it take to double your money, okay, if you invest $2,500 at 2.5% compounded annually. So if you invest $2,500 at 2.5%, all right, compounded annually. All right, so there's your little financial problem there. And this is one of these classic problems that involves logarithms, okay? So here we go. Let's write down what we know and what we don't know, and let's tackle this problem together here, okay? And you're gonna see that there's a couple different methods involved. or that can be used. And this one deals with compounding annually, but we can also compound monthly and we can compound continuously. So in this case, on this type of problem here, which you're going to see later on, we got to be able to handle it in multiple different ways. So what we do know is this: we want to invest this much money here. So this is our present value, or our principal. We know that the principal is $2,500. This is a doubling situation here, so that's obviously a keyword right there. So if we want to double our money, what do we want for in the future here? B is always our future value. P is either principal or present value. So if we have $2,500 in the present and we want to double it in the future, how much money do we want? There we go, Mia, Madeline, Mondo, there we go. Yeah, 2 times 2,500 is 5,000. So there's your future value. Your interest rate is right here in the problem. It's 2.5%. So we know that R is equal to 0.25. 0.025, but that's what I meant to say. You shift that decimal 2 places to the left. All right, and it's compounded annually, meaning once a year. So that tells me that n is equal to 1. Semi-annually, twice a year. Quarterly, 4 times a year. Monthly, 12 times a year. So there's different problems involved with this. This is just the first of many. Okay, so now what we need is we need the compound interest formula. So who's got that memorized? Who's got the compound interest formula memorized? B is equal to something. We need it right now. Can anybody just bust that out off of memory? Very good, Mia. Very good. So B is equal to P times 1 plus R divided by N raised to the NT power. This is your compound interest formula. Now, if speaking of study techniques here, study methods here, if you don't have all your formulas memorized, then I would highly suggest that you guys take a sheet of paper tonight. No problem, Jacqueline. Take a piece of paper and organize all your chapter 2 formulas all on one page, fully labeled, and have that on your desktop if you don't have them all memorized. I'm talking about from section 1 all the way to now. Okay, because you need to have this stuff like either at your disposal real quick or in your head, one of the two. All right, so here we go. Let's set it up. We're going to substitute in the future value for B. Okay, this is your future value, and we want 5,000. Oh, wait a minute. Hang on. Stop for a second. There's two. We're going to do this 2 methods here, guys. So let's split the paper here. We're going to do this 2 different ways. So let's write down method 1 over here, and then method 2 over here. And there's a reason for this. There's 2 ways to solve this, at least. All right, and we're going to go through both methods here just to show you how it's done 2 different ways, but also to highlight something important here. So we got to get through it. So here we go. Method 1, using, well, I'll get to that. So 5,000 here is the future value. We want to double our money. So if we start off with a principal of $2,500, the question is how many years later, that's T by the way, how many years, T equals question mark. So we got to solve for T, okay? So in how many years will it take to double $2,500 to $5,000? So this is going to be multiplied by 1 plus R divided by N. So 0.25, divide that by 1 because it's once a year, it's annually. And raise that to the NT power, where N is 1, because we're doing it annually. So it's going to be 1 times T or just T. Now let's just simplify this just real quick here. We got 5,000 equals 2,500 times 1. 1 plus 0.025 is just 1.025. I'm just simplifying here to the T power. Okay, here we are. So notice the variable that you have to solve for is in the exponent. And This is called an exponential equation or an exponential function. And anytime you're solving for an unknown in the exponent, it involves logs every single time. And that's why I started the lesson off with logs, because you need to be able to handle that. Now, what I would do if I was handling this by myself, I would simplify a little bit further. I would divide both sides by 2,500, because that would simplify the calculator work immensely. So simplify a little bit. Okay, help me out a little bit here. What's 5,000 divided by 2,500? There you go. Good job, you guys. It has to be 2 because we doubled it. So 2 is equal to 1.025 to the t power. Oh my God, that looks better. Okay. Now, the variable's in the exponent. And anytime you solve an equation where the variable's in the exponent, it always involves logs. And one way to do this is to take the common log to both sides, base 10. The second way to do this is to take the natural log of both sides. So here we go. I'm going to use go base 10 common log. So I'm going to take the log of the left side, so the log of 2, and I'm going to take the log of the right side, which is 1.025 raised to the t power. Now this is base 10. It's called the common log, okay? When you don't see the base, like on your TID4, if you look at the log button, you don't see a base 10. You're supposed to know that it's base 10. Okay, so your Algebra 2 teachers and pre-calc teachers should have told you that the common log is base 10. So let's just keep that in mind. All right, so what shall we do? What shall we do? What can we do with this variable here? Where can we shift it? Talk to me, guys. We just talked about this earlier. Where can we shift the exponent? Ah, there you're back. Okay. Everything good, Jacqueline? Okay. You're right, Christian and Natty. Very good. It shifts to the front of the log. So it shifts right in front. So I'm going to rewrite this expression as log of 2. Notice how I'm saying this now. You guys should be talking to yourself on the other side of the computer here. Log of 2. That's how you say it. Log of 2 is equal to, all right, t times this log of 1.025. Okay, and now let's highlight the variable. It's right here. It's t times the log now. Our goal is to solve for t, which is the number of years it will take to double. T is the number of years it will take to double. So what do we do? What's your algebraic step here? What do we do? Think algebra 1 now. Think simple. Very good. Yeah, see, divide by what though? Be specific. Which log do we divide by? Might be, yeah. So there you go. Well done. Well done. So let's do what she said. Divide both sides by the log of 1.025. Both sides, in algebra, as you guys know, you do the same thing to both sides. Be balanced. And don't worry about the numbers because we use the calculator to do the hard work, right? On the right side, these logs divide. Anything divided by itself is 1. Okay, and then we let the calculator do the work. So here we go. Turn your T84 on or Desmos, either one. Enter in, let's use that common log, not ln, the natural log, just use the regular log, the common log. And 2, on both Desmos and the T84, you got to close off the right parentheses before you hit the division button. So pay attention right there. Take log of 2 divided by, and the log of 1.025. Okay, and type your answer in the chat. What are you guys coming up with? Take it to the nearest 100th. Oh, there we go. What do you guys think? Oh, yeah, you guys are agreeing with each other. Okay, I agree with you guys too. So a little over 28 years, 28.07 years. Good job. So 28.07 years. All right, to double. Okay, so now that's dealing with the base 10. there's two bases on your calculator on the front side of your calculator. On the left side of the T84, there's the log button, the common log, and then there's the natural log. So method 2 uses the natural log. Okay, so here we go. Let's work on this one together. So we're going to start off with the same thing here. So this obviously doesn't change. It just looks a little bit different as we get through it here. So 1.025 to the t power. So starting with the same equation, but we're gonna solve it using the natural log and not the common log, and hopefully we're gonna be able to see something. Okay, so we're gonna, simplify again, do the same few steps here. That doesn't change. Always simplify it first. At least I would do that. It's easier to input on your calculator. This is the point where we want to, instead of taking the common log of both sides, we're going to take the natural log of both sides. So this is where it's going to look different. So here we go. We're going to take the natural log, ln, natural log of the left side, take the natural log of the right side. So notice the difference. Oops, didn't mean to do that. I took the natural log of both sides. So let's see, let's use the same techniques, okay? At this point, what do we do? Dun, 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 dun. Kyle, help me out here, buddy. What do we do at this point? This is why I don't, come on, Kyle, help me out here, buddy.
I'm not sure.
Look on the left side. Look at this step right here. What do we do? How did we get from here to here? From on the left-hand side, we had log of 1.025 to the t power, and it became t times the log. So what happened right there?
You move the t over to the front and you divide the log.
Yeah, and then we divide. So we need to do that over here. So help me out. How should this next step read? So natural log of 2 is equal to what on the right?
Equals t log 1.025 divided by log 1.025.
Should we say log or should we say natural log?
Natural log.
Yeah, the natural log. So good. Okay, thank you. So we're going to divide by the natural log of 1.025 on both sides. All right, everybody go to Desmos or the TI-84. Let's figure this out, okay? Now hit the natural log button, ln. Okay, natural log of 2, close off the parentheses, and then divide by the natural log of 1.025. And you'll notice that we get the same thing right here. On Desmos, same thing applies. You hit you go to the function button, you select natural log, ln, you type in 2. So you go back to the main screen, hit 2. You got to close off the parentheses on either calculator, it doesn't matter which. And then you divide it by, again, hit the function button, select natural log, and then type in your number, 1.025, and you'll notice that we get the same thing. Okay, about 28.07 years. So what does this tell us about which log we pick? The first method, we use base 10, common log. Second method, we use the natural log. What does that tell you if we get the same answer in either way? What does that tell you? What should you learn from the side-by-side comparison? That's true, Kylie, but what else? They both equal 28.7 years. We get the same result. On the left, we use base 10. On the right, we use base E, the natural log. Haha, yes, Geronimondo, yes. You can use either base. You can use any base you want. I chose base 10 because it's on the calculator. I chose base E secondly because it's on the calculator. All right, those are the two function buttons that you have on the front of your calculator. So you can use either base, okay? Either base can be used. So keep that in mind, because when you do your problem solving later on, okay, you could use either base. All right. Now this first example that we worked through here together, guys, deals with compounding annually, but there are better ways to compound your money. Can you guys tell me a better way? What's better than compounding annually? You should have learned this in the previous sections. What's better? To make more money, or to get the same amount of money?
Continuous compound.
Yeah, that's the best. All right.
Yeah.
What's in between? What's in between continuously compounding and annual compounding?
It was the one with the E. I forgot what it was called. It was like
But no, that was it. That was it, Matthew. It's the continuously compounding. But what's another way of compounding your money? Not annually, but
daily.
Daily. That's one. What else is another one?
By like seconds.
Yes, or monthly. Look at the chat. So we can compound it continuously, monthly, daily, semi-annually, twice a year. I mean, and the last one we talked about, we can compound it. Yes, quarterly. Okay. There's a lot of different ways. So let's change the problem a little bit here. Okay, here we go. Next one, number 2, or we're actually at number 4. Okay, so let's state the problem. Okay, so how many years? Okay, will it take? All right, and let's change it up a little bit. Instead of doubling, let's triple. So how many years, okay, T equals question mark, will it take to triple? To triple your money. All right, if you invest $12,000, so if you invest $12,000, there's your principal now, okay, or your present value. So if you invest $12,000 at, let's say, 1.85% compounded monthly. So we're just going to change it up a little bit, because you guys need to be able to handle different situations, whether it's quarterly, monthly, daily. You know, it doesn't really matter. It's the process is the same, but the results are different. Okay, here we go. All right, so let's do what we always do here. Let's write down what we know. Okay, the present value, or the amount that you have initially, P, is 12,000. That's your principal that you want to invest. That's the present value of your money. This time, though, we want to triple. So what's the future value want to be? What do we want the future value to be? Good, you guys are thinking ahead of me. Very good. I love this class. Okay, so B, the future value is 36,000. You got to multiply that principal by 3, because we want to triple our money. This is the future value. And P is the principal or the present value. Okay. The interest rate is 1.85%. So R is 0.0185, because we're given 1.85%. I'm just translating things in my mind as I read the problem, like I always do. This is how I approach every single word problem. And I underlined the key words. We're compounding monthly. So what's n equal to in this case, you guys? There you go, Alyssa. There you go, Elijah. Yeah, there you go. So n equals 12 because there are 12 months per year. Now, what I suggest you guys do is you just write down this formula every single time, the compounding formula, because it'll help you memorize it. You'll memorize things a lot quicker than if you just keep it, if you do not write it down, so write it down every single time. And it helps you organize your thoughts too, because you gotta start with the right, financial formula. Okay, so we want 36,000 in the future. We're starting off with 12,000. The question is how many years will it take to triple our money from 12 to 36,000? So we're gonna have to multiply this by 1 plus 0.0185 divided by 12, because, well, we're doing it monthly now. There's your monthly periodic rate, or your monthly interest rate. And then raise this to the 12t power, n times t, 12 times t. So notice that t is in the exponent again. Whenever they ask you for a length of time on an interest problem, they're always asking you to solve for the exponent, which means you're always going to use logs. That's why I started today's lesson with the discussion on exponents and also logs, because in section 9, it is all logarithmic, okay? So what can we learn from the previous problem? What would you guys do first to simplify this? What's something that we can do to make this look a little bit more friendly?
Move the t to the front.
We could. We're going to do that. Hold that thought. Before we do that, what can we do first to simplify or just make a problem look a little bit user-friendly? Everybody read the chat. Okay. So let's divide by 12,000, and then J-Ron, let's do what you said. We're going to do that in step 2. So let's divide, just make it a little bit easier to handle. Okay. 36,000 divided by 12,000 better be 3, because we tripled the money, okay? And then we have something that looks a little bit more user-friendly. Okay, so 0.0185 divided by 12 raised to the 12t power. Now, before we shift the exponent, J-Ron, before we shift the exponent, we got to take the log of both sides, because that's a log property. And there are no logs in the equation yet. So we need to make a decision now. Do you guys want to do it like the previous problem? Do you want to use base 10 or do you want to use base E? Because we don't have to do both. We just need to make a choice. Because as we found out, we can use either one. So I'm going to let you guys choose. So Getsy, choose for the class here. You choose base 10 or base E?
Base 10.
Okay, here we go. We're going to do base 10. All right, so let's take the common log of both sides. Here we go. So log of 3 on the left. This is base 10, or the common log. So we take the log of the left side, we take the log of the right side. And again, it doesn't matter what base you use, as long as you step it out correctly. And Getsy chose base 10, the common log, but if you wanted to do this with the natural log, you're going to get the same answers. Okay. Now at this point, J-Ron, this is when you shift that exponent. So would you help me out? How can we rewrite the right-hand side?
The right-hand side would be, wait, your right or my right?
Both of ours.
Well, I would go like log 3 is equal to t log, or it'd be either log t or t log, and then in the parentheses 1 plus 0.0185 divided by 12.
That's close. What we want to take that entire exponent and shift it to the front.
Oh, you're taking the 12 too. Okay.
Yeah, the entire exponent. So try it again.
So it'll be log 3, 12 log parentheses 1 plus 0.0185 over 12.
Close. So 12t times the log. We're going to take the entire exponent.
Oh,
The entire exponent. So 12t times the log of all that stuff in there. Okay? Does
Yeah.
that make sense to you? You got to shift the entire exponent. Okay. Now, now what do we do? Let me highlight the variable. We're trying to solve for this t right here in blue. What do we do at this point? What would you guys do?
You divide log parentheses 1 plus 0.0185 divided by 12 with log 3.
Okay. We could definitely do that. So I would do that, but a little bit more. So let's pause right here before we go any further. That is something we definitely need to do, Christian. But I want to, that would get these logs canceled. That would cancel out the logs there, but I'd end up with 12t on the right, not t. So what else can we divide by to just isolate t all in one step instead of two steps?
Oh, you could divide by 12.
Yeah. Okay, so let's do that. I'm going to divide by 12 times the log. So include the 12. So these 12s cancel out as well. That would isolate t in one step. See? So believe it or not, you could do that. Okay, you can divide by that entire thing. So believe it or not, even though this expression looks kind of ugly, it actually is doable easily on the calculator. So let's bring up the Desmos, or you guys can use your TI-84, it doesn't matter. Let's type it in. So here we go. This time, go to function, enter in log, this time log of 3. Okay, you got to close off the parentheses now before you hit the division button. So divided by 12 right here times the log. So hit function log and then that number in there, 1 plus 0.0185, excuse me, divided by 12. And you should get this. Now, for my TI-84 users out there, and I'm sure some of you guys are using the TI-84, if you're not getting 59.43, you need to let me know because I probably know what's going on. Is anybody using the TI-84 but not getting that result? Okay, so Priscilla, let's talk to each other here. So turn your mic on here.
Hi.
So check this out. You're using the 84, right?
Yes.
Okay. Now watch me, okay? I'm going to enter in log. And I'm going to type in log of 3. Did you close off the 3 first of all?
Yes.
Okay, just keep your eyes on my calculator here. So I'm gonna divide it by. Now, at this point, did you just enter in 12 and then log of 1 plus 0.0185 divided by 2? Is that how you entered?
That's how I entered it, and then
You got this number here, crazy number, right?
yeah.
Okay, so this is what happened. So watch this again. I'm going to do it correctly now. So log of 3, I'm going to close it off and then divide it by. And what we need to do, this is the key, is you need to put parentheses around your denominator. So hit the left parentheses button and then type in 12 and then log. And then enter in 1 plus 0.0185 divided by 12, and then close it off twice. 1, 2. Now hit the enter button. Did you get 59 point something?
I'm still entering it in.
Okay, no worries. Take your time.
Okay, yeah, I got it.
Okay, so the key Let me go back to my expression here on the calculator. See this? See where my cursor is? That when you divide by the denominator, you got to start with parentheses on there. You got it?
Got it. Thank
All
you.
right. Yeah, you bet. Okay. So like I said, if you have any calculator issues, you got to talk to me because I usually can help people out. Okay, and we're going to, what do we get here? So 59.43. So we got 59.43 years, all right, to triple your investment. Okay, let's pause here and ask any questions. The first example, we did a compound annual example. This one, we compound monthly. It's different, right? A little bit different. And there's many different ways to do this. And so that's why I'm doing this today, to give you guys some good log experience, because section 9 is not the easiest section in the world if you don't review enough on logs, from the past. Any questions up to this point? Talk to me. Give me some kind of feedback. Either a thumbs up or ask questions, something in the chat, something out there. As you can tell, the problem solving is a lot more demanding in this section. So that's why I'm giving you guys time to process, try it on your calculators, take good notes, ask questions if you need to, all that sort of thing. Okay, let's take a look at the last type of problem. Well, it's not the last type, but another type that's different than what we've done. So let me pose the question. So how many years? Okay, so how many years will it take to quadruple? Do you guys know what that means, quadruple? Okay, there you go. Okay, just making sure you guys are correct. So in how many years will it take to quadruple your money? All right, if you invest, let's say $4,500 at 4.25% compounded continuously. So this changes things right here. So now this is a compounded continuously situation. So let's write down what we know and determine, what we need to find out. So this is in how many years? That's T, question mark. We got to find T. We know the principal is right here. This is P. The principal is $4,500. What's the future balance going to be, guys? What do we want in the future if we want to quadruple it? Help me out here. Very good. 4,500 times 4 is 18,000. So we want 18,000 in the future. This is our future value. Present value, the principal is 4,500. If you want to quadruple it, you want 18,000. But the question is, like, after how many years will this happen? Okay, the interest rate is 0.0425. 0.0425. You're given the interest rate right here. But we have a new formula here. So what is our compound interest formula for continuously compounding? Wow. The people that have been participating in the chat are doing super. Okay. Look at that. So let's write it down. So here we go. This is the key word right here. So B is equal to P times E to the RT power. I'm going to keep on saying this because I'm hoping that you guys will try to develop your good study methods over on your end at your house. You need a single sheet, a formula sheet with all the main formulas from the chapter 2 all on one page, all labeled, annotated, so that you guys can do your homework effectively, so that you guys can test effectively or quiz effectively, so you have it all there. If you haven't done that, then I suggest that you guys do that. Okay, so here we go. Let's put in our numbers and let's do some mathematics here. So we want $18,000. If we invest $4,500, there's your principal, times E, Euler's constant, to the RT power. So 0.0425 times T. So notice the exponent. Okay, your goal is to solve for T, the number of years, and it's in the exponent again. And anytime the variable that you guys need to solve for, if it's in the exponent, it involves a log every single time. Always, you should make a note of that to yourself. Always involves a log. Okay, so let's see if you guys have learned some simplifying tricks today. All right, what should we do first to simplify the equation so it looks more user-friendly? What can we do? Simple things that we can do to make it more, easier to look at, easier to put in the calculator and all that kind of stuff. Very good idea. Good job. So let's do that. Let's divide by 4,500. This is going to simplify things greatly. 18,000 divided by 4,500 better be 4 because we're quadrupling. Okay, quadrupling. That's why that 4 is coming out. And that's going to be equal to e to the 0.0425 t power, to the power of 0.0425 t. Okay, now before we shift any exponents, okay, we got to take the log. So you guys got to make a decision here. Like on the last example, Getsy chose base 10, so we took the common log of both sides. Let's change it up this time. Let's take the natural log of both sides, just to kind of change things up. Okay, so let's take the natural log of both sides. So you're going to see me do that. So here we go. I'm going to take the natural log of 4, and that's going to be equal to the natural log of e to the 0.0425 t. So I just took the natural log of both sides, base e. Now what should we do? Give me a suggestion. Use a log property. What should we do? Christian and Getsy are right on track using the log property. So here we go. We're going to take this exponent here and shift it to the front. Okay, so we've got the natural log of 4 on the left. And now if I rewrite the expression on the right, I get 0.0425 t times the natural log of e. Okay. Now let's simplify this a little bit. You may look back at your notes from earlier today in the beginning of the lesson here. What's the natural log of e? Try again. Yeah, let's make a little note on the side. Okay, the natural log of e is equal to 1. Because remember, it's log base e of e. So if you take e to some number, e to some power, if that's going to be equal to e, well, then x has to be 1. The natural log of e is always 1. You can check that on the calculator too. In fact, I'll do it right in front of you. You type in natural log, and then you put an e in there. There's somewhere around here. Oh, well, right above it is e to the x. So go second e to the x there, or second natural log. You could type in 1 if you want, and then you'll get 1. Okay, natural log of e is 1. It's one of those, it's one of these basics that you got to either understand or memorize, one of the two. I would suggest understanding it, but you just need to know that. So that's 1 right there. So let's simplify it. So I've got natural log of 4 is equal to 0.045, excuse me, 0.0425, all right, times t. And we're 1 step away from the answer. Okay, help me out. Let's finish strong here. Dun, 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 dun. I'll give you guys a drum roll. What do we do? Yes. Okay, so let's divide by 0.0425 on both sides. And what do we get? So go ahead and put that answer in the chat. Okay, what is this? Go ahead and round it to the nearest hundredth like you always do there. What are you guys coming up with here? Natural log of 4. Make sure you close off your log on your calculator before you hit the division button. Good job, you guys. Okay, so roughly 32.62 or 32.6 years. So 32.62 years, all right, to quadruple your money. All right, let's pause here. That was, we've done a lot today. Can you imagine not having today's session and going right into your workbook and doing all this with financial problems, just boom, with no prep? Can you guys imagine what would happen? I don't know. What do you guys think on the process there? We're probably a little tired today, aren't we? Yeah, I know. Listen, hey, I'm right there with you guys. I have to do this just as much as you do, believe it or not, because I teach 3 classes a day, and I know what it's like going through 3 1.5 hour sessions, and then I still have to work 2 to 3 hours on the computer every night, designing stuff for you guys. Yes, you. Yes, yes, yes. And so it's usually more like 4 hours, Christian, to be honest with you. Like last night I was working on my iPad grading. I was grading in my break today. I was developing stuff. I got up at 5 o'clock to develop all this for you guys here. I mean, teachers, at least I do a lot to get ready for my classes. And so, but I get it. I have compassion for you guys because being a student is not easy either. Okay, it's not easy either way. Okay. Now I want to test your understanding today. So here we go. We got a little mini quiz here, little quizaroonie. All right. Quizaroonie is a little mini quiz if you guys don't know that word. Can you guys say quizaroonie? Okay. Jacqueline, are you okay? Did I just break your heart right there when I said that? Oh man, I'm sorry. Okay, it's going to be short. Okay, it's going to be short. I apologize. I know. I just want to test your understanding and make sure you guys are getting it. That way I know what to do on Tuesday when I see you guys again. Because unfortunately, I have to wait a few days in order to see you guys. Okay, so here we go. Just continue us on the same paper here because you're going to submit everything here in a minute. So here's a little quizaroonie right here. Okay, so basically the same type of problem. All right, this is a doubling problem. Go ahead and take a moment and write that down. So the question is in how many years will it take to double, for your money to double if you would invest $2,600, That's your principal right there. $2,600 is your principal. And if you do it compounded annually in part A, compounding monthly in part B, and compounding continuously in part C. So I ask you to do it on your own here based upon what we've done today. We've done all three of these cases. And what I want you guys to do is just give it a shot. And then when you're done, before 2:30, you can go ahead and just upload that entire thing up there. And then I can take a look at your work and then give you guys some feedback. And then I'll know on Tuesday, when I see you guys, I'll know where our strengths are, where the weaknesses are, and then I know how to adjust. So the good thing is you get to use either Desmos or TI-4, you get to use your notes. I did an example for each one. I'll tell you what, I just noticed the time. It's already 2 o'clock, so we've already got an hour and a half. Yeah, you guys probably need a little stretch break, probably. Okay, I'll tell you what, I'll change the due date from 12:30 to, from 2:30 to like 4 or something like that. That'll give you guys time to do a little stretch break and then come back to it and get it submitted. Is that fair? So you guys can go do some calisthenics or something like that and then get some water, hydrate, do some push-ups, run around the block maybe, I don't know. So 4 p.m. deadline, write that down. I'll change it to 4 p.m. instead of 2:30. I think I said it at 2:30. And then let me do that right now so I don't forget.
Can you go back? I wasn't done writing down the.
Oh, sure.
Sorry.
Go ahead. Yeah, no worries. I'll change it here in a minute. I'll just make sure you guys have, time to take a little break and then get back to it. Make sure you scan all your notes with this, put it all together. Make sure you sign, put your name on there, and then whenever you're done today before 4 p.m., you can submit all your work, and then I can take a look at it and give you guys some feedback. All right. So as soon as you're done with that, you can feel free to log off and do what you got to do. If you need to get a hold of me over the next 4 days, you can obviously send me a message through Remind or through Canvas. If you need anything, I'm around. You know how to get a hold of me. So you guys were fun today working with. You guys did a good job in the chat and Orly, all of that. And okay. Well, I'll tell you what, I just had a few requests because of some things coming up. And that sounds pretty darn important, Charlie. So yeah, that's fair. That's not a problem. I'll give you guys a little bit more time than 4. I'll make it 6 p.m. instead of 4 p.m. so they give you plenty of time. Just be responsible. And if you have nothing to do, what I suggest you do is just take a quick break and then, get right back to it. Make yourself proud, turn it in. It feels good when you turn it in. Okay, trust me, it does. And so I'll adjust it to 6 p.m. Okay, any questions or needs before you guys head out? Okay, leave me with a smile. Leave me with some smiles out there. I got a couple out there. There we go. Okay. I'll see you guys. You guys take care. Have a good weekend. And I'll see you guys soon.
Oh, okay, so for that quiz, I redid like problem 1 and I hit like resubmit for the chapter 2 part 2 test.
I'm trying to think.
Because I got like a 70 on it, so I just redid the first, and it was only the first question I got wrong. So I redid that, and then yeah.
Are you talking about your quiz, Matthew?
Yeah, the quiz, not the unit test, the quiz.
Oh yeah, because didn't we talk about that last time?
Yeah.
Okay, I'll go
So
back.
I did that.
Okay, I'll go back and take a look at it and give you some
Okay.
feedback on that.
Okay, cool.
All right, give me a few minutes to work on that. Sound good?
Okay. Yeah. Okay. Cool.
All right. Anything
Okay.
else?
Bye. No, that's it. I'm good.
Good job today, Matthew. Have a good one.
Okay. Thanks. You too.
Okay. Okay. Bye-bye.
I left and then I remembered I didn't even write down all the questions yet. I started on number 1 and then I left and then I don't have the other ones written down yet.
Okay, well, go for it, buddy. Go for it.
I was writing these down real quick.
So do you use your phone to connect to Zoom?
I'm on one of the school Chromebooks now.
Oh, it's just on your lap or something?
Yeah, I have this little like wooden like mini desk thing so I can write.
Oh, that's
Yeah, so
cool. That's cool.
Okay. Yeah, I got it. Yeah. Okay.
Awesome.
Thank you.
You're welcome. Listen, you have a good weekend, all right?
You too.
All right. See you, Jaron.